In this lesson, we're still going to be working with formulas, but we're not going to be given numerical values to plug in and solve for one of the unknowns. Instead, we're going to manipulate the formula itself. So let me give you an example. Let's take the formula A is equal to B times H. If I said that A is 20 and B is 4 and find H, I don't think you would struggle with that at all. You would say, okay, here's 20 is equal to 4, and I don't know H. Solving for H, you're going to divide by the coefficient. You're going to perform that, and you get, 5 is equal to the height. What if instead you were given the formula A is equal to BH, and you were told to solve for H, but you were not given numerical values for A and B? You're supposed to remember that H is the unknown, and you're going to do exactly what you did over here, but you're going to do it with letters. If H is the unknown, what is B's relationship to it? It's not being added to it, it's being multiplied by it. It's the coefficient. So you would divide by B. You have to divide this side by B. All right, it does divide out, and we get H just like we did over here. But another difference is A divided by B. Now, 20 divided by 4, I know that's 5. A divided by B, I have no idea, so I leave it as A divided by B. I have solved for H in terms of the A's and B's. So you're going to do exactly the same steps, but it's going to be much more abstract. Let's take a look at this. All right, the first one, it says F is equal to 7GH, and it says solve for H. That means that H is like your unknown. Everything else is to be treated as a number. What is its relationship? Well, the 7 and the G, if those were numbers, I would multiply them together and get a single number, but I'll just have to treat it as 7G. 7G is being multiplied by H. So to get H alone, I need to divide by 7G. I'm doing the inverse. All right, that's gone, and I have H is equal to, I can't perform that division, so I leave it as F over 7G. So over here, you're going to have to use your little fraction tool and put these letters in. Okay. The next one, very, very important. In chapter 3, we're going to work with equations like this, formulas, all the time that involve x's and y's, and most often you're going to be asked to solve for y. And this says solve for y. So you're going to get used to doing this. Well, what's going on between this term 6x and the y? Well, the 6x is being added to it. So to get rid of it, I need to subtract 6x. That's gone. And I have y is equal to, now you could write this one of two ways. 6, those are not like terms, so I can't really subtract, I can just leave them. Or y is equal to, put the variable term first, and it's negative 6x, put the constant term last, and it's positive. You might wonder, why in the world would I consider this one? It's because I know what's coming up in chapter 3. It is customary for it to be y equals the x term first, then the constant term second. So I think it's a good idea to get used to that. This is negative 6x plus 6 is what y is equal to. Okay. Number 3, I have v is equal to xrt. Well, the unknown, they tell me over here, the unknown is x. Well, r and t are both getting multiplied by x. Usually the coefficient is on the left side, but it just happens to be on the right side. You're still going to divide by RT. And if you divide that side by RT, you're going to divide this side by RT. Those divide out, leaving me with X. I don't know what that quotient is, so I will leave it as V divided by RT. Last one, I have 4x plus y is equal to 9. I'm supposed to solve this for y. Well, what's going on? This 4x is positive, so to get rid of it, I need to subtract 4x. Those are inverses, so that's gone, and I have y is equal to, you can put these in either order. I'm recommending that you put the x term first, it's negative, put the constant term second, it's positive. So y is equal to negative 4x plus 9. That's all the practice we're going to do on that now. You're going to see a lot more of that when we get to the next chapter.